Am I really doing another video about T-nuts? Is this the fourth one? I swear this is going to be interesting. Just stay with me. Hello, Internet. My name is Quinn, and this is Blondihacks. Yes, I do actually need some T-nuts for my shaper, but this video is not really about making T-nuts. It's going to be a walkthrough of the shaper, show you some things that it can do, and it's also a nice excuse to make a project with older, more traditional methods. In the mid-century kind of period of model engineering, home machinists did not have milling machines. They really hadn't been invented yet, at least not at the scale that the home gamer could use. So they had things like shapers, and they would do everything on that machine and a drill press and their lathe. Of course, prior to the 1950s, for 100 years or so, model engineers got by with just a lathe and a lot of filing. But we're not going to go back that far, so I'll show you how someone might have made T-nuts like this in 1950-ish. So let's go. When I installed this new vise on my shaper, I stole the T-nuts from my small rotary table because they happen to be the same size. But I actually need those T-nuts back, so let's go ahead and make some new ones dedicated to this machine. T-nuts, of course, have shoulders, so I'm going to grind a new tool bit, which will make it easier to cut shoulder features on the shaper. I dug through my bins of high-speed steel scraps and I found this nice piece of Momax. Previously, you saw me using a narrow roughing tool, as shown in the shaper manual here, but I'm going to now grind an offset roughing tool, specifically for right-hand cutting, as shown here. It has one side that is square to the tool and allows you to cut up to a 90-degree shoulder. High-speed steel blanks generally have this 10-degree end clearance on them for you because every tool bit needs an end clearance. It's usually very helpful, but in this machine, it's not going to be helpful because this shaper has this shop-made tool holder on it, which conveniently holds the tool at a 10-degree angle, which is a very nice idea for a shaper tool holder. What it means, however, is that the end clearance needs to be higher. If I put that blank back in here, you'll see with the tool bit at a 10-degree angle, that 10-degree end clearance now becomes flush. So it's going to rub. So I'm going to be putting more of an end clearance on this piece than that. But other than that, this is going to be a pretty standard single point cutting tool grinding operation. For this type of thing, I like to actually lay out the angle I'm going to cut. Just gives me something to eyeball, something to aim for over on the bench grinder. These angles don't have to be all that accurate, but just helps me get things lined up. Now the end clearance is set with the tool rest angle. If you watched my video on grinding tool bits way back in my lathe skills playlist, then you know that the secret sauce for doing this really easily is to set your tool rest to the end clearance angle. And that automatically creates all of the compound angles that you need around the cutting point on the tool. I'm going to use a little less angle than I did on that other tool that you looked at. It had a lot of end clearance, more than is necessary. You need enough clearance to keep the end of the tool from rubbing on the work, but if you have too much, then the end of the tool becomes weak and it will dull quickly. So you want as little end clearance as you can get away with, basically. The cutting edge will last a lot longer and you can take heavier cuts if there's more material behind it. This is an extremely simple geometry, however, so all I got to do is grind one face down to that layout line. That's why shapers are so nice for the home gamer, at least back in the day, because you couldn't buy complicated end mill cutters and such. You wanted simple, cheap, single-point tooling that you could grind at home. Now you can also see why that 10-degree forward angle on the tool holder is such a good idea, because it means I don't have to grind a top rake on this tool. 10-degree top rake is kind of a good all-purpose kind of thing that will work on most materials. Pretty much everything except brass is going to be perfectly happy with 10 degrees. That means all I have to do is grind the side clearances on this tool and put a little bit of a nose radius on the end, and we're basically done. I'm also adding a side clearance along the vertical edge of the tool. If you're taking heavier cuts that go deeper than your nose radius, then this side of the tool becomes your cutting surface, and thus you need clearance behind it as well. I use a 60 grit aluminum oxide wheel for grinding high-speed steel, which works perfectly fine. However, I do also have a 300 grit diamond wheel sitting right here on the D-bit grinder, so I like to hone up the surfaces a little bit, touch them up on this guy. Completely optional, just a luxury because I have the machine. And then I finish up with some honing by hand to put a really nice sharp edge on that. There's my finished cutting tool. Hopefully all of my clearance angles are going to work out. We'll find out shortly. The notice radius, I just eyeballed something that looked about right just from experience of grinding these kinds of tools. Here it is vertically as it will be positioned on the machine. And into the machine it goes. It's going to be cutting on the left edge as shown on your screen there. And you can see it's a nice fit in the clapper box. And well, let's get this thing set up and see if it'll cut. This is normally the part of the video where I pre-stage the material I'm going to use in my scrap box and make it look like I went through my scrap box and found it. However, this time I actually didn't have a suitable piece, so I had to go back to the virgin stock rack. It's never something I like to do. I always like to use the scraps if I can, but well, here we are. And coming through. You can watch, but you got to stay out of the way. This is such a long piece, I'm going to have to use the big old horizontal bandsaw to lop a chunk of it off. And yes, I'm cheating here. The 1950s hobbyist would not have had this machine or anything similar to it. They would have done this with a hacksaw. If you ever wondered why your grandpa's right arm is super buff, now you know. Initial setup of the stock is pretty much like a milling machine or any other more modern machine. You just place the stock in there on some parallels, tap it down. Now we can set up for the cut. Now, this being a shaper, we need to set the ram. The ram has a stroke and a position, both of which we need to set first. These adjustments must be made with the machine at the rearmost position on the stroke, so I wind it back by hand to get it into that position. The first thing I'll adjust is the stroke length, which is shown here on this scale. It's currently at 5 inches. This scale is only valid when the ram is at the rear of the stroke. Now, stroke length is set with this control here. You can see it's marked shorter and longer. The knurled ring is actually just kind of a jam nut. The adjustment is that center shaft. It's a left-hand thread, so I crank it to the right to unlock it. And this control is a little tricky. You have to crank the center shaft to adjust the stroke length, but the knurled nut has to have room for you to do that. So you have to kind of back off the knurled nut, then crank the center shaft, and then once the pointer is on the right stroke length, then you got to remove the slack from the knurled knob, tighten it back down, and then retighten the center shaft. This is all very confusing, and the instruction manual was extremely misleading on how this control works, so hopefully that helps you if you ever have one of these things. A reasonable question would be, why not just leave the stroke length on the longest setting, because that'll cover all cases, right? We don't want any more stroke length than necessary because that just costs you time. Anytime the tool isn't cutting is wasted time, so you want the stroke length to be just a little bit longer than your workpiece. Now we have to set the stroke position. However, a given stroke length can be positioned anywhere in space within the range of the machine. And that's important because at the leading edge, you need a little bit of space to give the machine some run-up. The motion of the ram is sinusoidal, and it needs a little bit of time before it touches the work to accelerate up to full surface speed. For this machine, the manual recommends somewhere between 1/2 inch to 1 inch of lead space. We also need some runoff area at the far end of the work, because at the far end of the stroke is where the step over starts on the table feed. The bulk of the cross-feeding step over happens during the return stroke of the ram, what's called the idle stroke, and that's also why the clapper box is there, because halfway through that idle stroke it's going to start dragging the tool over uncut material, so the tool needs to be able to lift up. However, that step over starts just before the end of the stroke. It's just part of how the mechanism works. So you need to give it a little bit of runout room so it doesn't start stepping over while the cutter's still engaged. That stroke position is set up here. First of all, we loosen this clamp on the lead screw that moves the ram position. And then this crank allows us to crank the ram back. Now remember, the ram is at the rearmost position of its stroke still. That's where we had set it on the drive pulley. So I crank it back until it's got 1/2 to 1 inch of run-up space. And then double check the far end. Same distance there. Looking good. Lock that down, and now I can set up the crossfeed. This eccentric here sets the amount of step over on each stroke, and this arm can be adjusted to either side of center because, as you can see, it's marked left and right. This has to be set to the correct side for the direction you're going to be feeding, because this sets the timing of when in the idle stroke that step over starts. If you're on the wrong side of center, then your step over timing will be wrong. The further over this is set, the more it will step over. And it seems analog, but really it's not, because this is setting how many gear teeth on the ratchet will be engaged on each idle stroke. And it's going to end up being 1, 2, or 3 teeth, which is 5, 10, and 15 thousandths of step over. So you just kind of have to eyeball it 1, 2, or 3/3 of the way across, and then you engage the feed with this lever here. Next up, we need to get the right surface speed. Just like any other machine tool, the surface speed of the cutter has to match the material. Now I'm going to be cutting steel, which for this machine means we want about 50 feet per minute. As every pirate knows, the correct ramming speed is very important. The manual has this crazy chart in it, and the reason this chart is necessary is because of how the mechanism of a shaper works. The ram does one full cycle of 2 strokes on every rotation of the mechanism, regardless of how long the stroke is. So think about that. That means the longer your stroke is, the faster that ram has to move to get a full cycle in one rotation. So that means surface speed is interdependent with stroke length, and that's why this chart exists. This chart tells me for a 4-inch stroke length, I need to be on pulley step number 3 to get roughly 50 feet per minute. So let's go do that next. Unlike a lot of machine tools, this is super easy to do. It's one nut, and this really nice factory belt cover hinges right open, and here's your pulleys right here. You don't have to loosen up any tensioners or anything, you just slide the belt right over, because this belt tensioning system is the clutch. You can see how if I move the clutch, it's going to tighten up that belt for us. So the belt's really easy to move, and you can see that's going to spin a little bit faster now because it's on step 3 instead of step 4. Yes, I know that belt is worn and needs replacing. Don't worry about it. At some point, I'll probably make a knurled thumb nut for that so I don't have to use a wrench, but for now, pretty easy. All right, we're about ready to do some shaping. I'll double check all of my settings by engaging the clutch, and everything looks good. So now I'm going to start doing my touch off. Just like any machine tool, you got to start with a touch off so you know where in space the end of that cutter is. You can do this by hand or under power. I'm doing it under power by moving the hand wheel down a little bit at a time on each idle stroke until the cutter just touches the work. Now I can dial in some depth of cut. I'm going to go 20 thousandths for this first pass. It's a nice safe number. I know the machine can do that comfortably. And away we go. I've engaged the power crossfeed and it's ticking its way over and it's going to start cutting. First couple of strokes imminent. Right off the bat I can see that that cutter is performing beautifully. There's no rubbing, no bad noises, and the chips coming off there look really good, so the tool grind was a success. I'm using the 5 thousandths step over, the smallest one, because this is essentially a roughing operation. I have a lot of material I need to remove off the top of this to get the height down to my final T-nuts. So for a shaper, the way you remove material as fast as possible is with a small step over and a high depth of cut. So I did a few experimental cuts as I went along, increasing the depth of cut a little bit at a time, and somewhere around 30 thousandths, the machine was happy. I know this machine can do more than that. I've seen it cut as much as 60, but it does require tightening up the drive belt a lot to do that, and I keep the drive belt on the loose side because the clutch works a lot better if the drive belt is looser, and I want to be able to at least somewhat trust the clutch on this thing. And a lighter cut is just easier on the machine. I'm not in a huge hurry here. 30 thousandths is just fine. Yes, I know the bench is still wobbling. Don't worry about it. Here's a look at the mechanism in the machine. Shapers are very clever. What may not be obvious is that the idle stroke, the return stroke, is actually faster than the cutting stroke, and that saves time, makes the machine more efficient. This mechanism is hard to see here because it's kind of covered up by that sheet metal there, but Wikipedia actually has a really nice article on shaper mechanisms and how they work. I'll link to that below. Just like any other machine tool, once I'm roughed in close to dimension, I'm going to check where I'm at, and then I'll set up to do a finishing cut. The depth of cut is set on that tool head as you saw earlier, so I'll dial in a nice light cut for this final pass, and away we go. This is the same 5 thou step over as before, but if you're trying to achieve best possible finish on a shaper, you actually do it in kind of an unintuitive way. You want to use the largest possible step over, and you use a very broad, flat tool, similar to what might be called a shearing tool on the lathe, and you take light cuts with it and you step over a large amount on each pass. Adam Booth has some great videos on this if you're interested, but this roughing tool is doing a perfectly fine job, so I left it as is. That finish is far nicer than T-nuts need to be, so it wasn't worth all the tool changing and such. Over to the surface plate, I'm going to copy the height of this center raised section on the T-nuts that I'm copying. I'm going to do some layout on the blank that I've just surfaced. I'm going to be cutting to a shoulder now on the shaper, which is not something I've done before, so I want a layout line to kind of aim for roughing in this feature. Shoulder cutting is kind of a new and exciting adventure for me on the shaper, so you'll have to bear with me as I learn how to do this a little bit. But there you can see the 2 targets that I have to hit. Fortunately, T-nuts are very low precision pieces, so I can learn as I go. I roughed in that shoulder to the correct depth and approximately the correct width using the exact same type of cut as you saw for surfacing the top. The only difference is I'm watching that layout line like a hawk and declutching right before I get to that line. Then I move clear the work again, dial in a little more depth of cut, and do another pass. Again, stopping short of my layout line on each pass so that I know I have room to do a finishing cut that will be on dimension. This is a little bit like a video game, trying to stop it at just the right moment. The finishing cut is going to be done vertically, and cutting vertically on a shaper is a pretty interesting thing. I've already done that first shoulder, so I'll flip the part around and show you how I do it on the second one. I could cut the other shoulder from the left, of course, but that requires changing my setup and grinding a different tool and so on, so it's just easier to flip the work in this case. That second shoulder was roughed in the same way. You don't need to watch it again, except that it's an excuse to show the shaper running some more. I'm ready for that vertical finishing cut now, and cutting vertically on a shaper is really interesting. You have to rotate the clapper box, and that's because on the idle stroke, that tool has to be able to lift up and away from the surface that you're cutting. So lifting straight up is not enough. That's not going to clear the surface because the tool is moving straight downward on each stroke. So the tool has to be able to lift both up and away sideways from that surface. That's why the clapper box can be rotated, and you got to do it for vertical cuts. So I'm touching off once again. Unfortunately, because I rotated the clapper box, I've lost my position, so all my hand wheels are invalid now, so I had to do a second touch off, but that's okay. Now for the actual cut, this is pretty wild stuff. I know my hand is on the machine, and this is the correct way to do it. I know it seems like it might be dangerous, but this is the correct way to do it on a shaper that does not have power downfeed, as most smaller ones do not. So I'm doing what the machine would be doing with the tool head on the power crossfeed, which is at the end of each cutting stroke, I move the cutter a little bit downwards. I have all of the length of the idle stroke to do that, but my advancement has to be finished before the idle stroke finishes, and I cannot start that movement before the end of the cutting stroke. Again, it's kind of a video game, but you get into a rhythm with the machine, and you get pretty good at it. You just kind of crank that handle a little bit on each stroke. This might seem like a difficult thing to do, like it requires a lot of skill, but it's really not very difficult. I managed to do it the first try. It's a bit like driving a car, or running an excavator, or running the hydraulics on a farm implement. Very quickly it just becomes muscle memory. You just kind of become one with the machine, and your body knows what to do. When I get close to final depth, I'm watching the markings on that hand wheel like a hawk and trying to make sure I land exactly on that right tick mark. You could also slow down the RAM, which would make this manual feeding easier, but that speed was okay. I wouldn't go any faster than that though. Now, sticking with traditional methods, once again, I'm going to do layout to mark the positions of all of the threaded holes in the centers of all these T-nuts. Of course, the modern hobbyist would throw this in their milling machine with the DRO on it and have these threaded holes done that way, but our intrepid 1950s home hobby machinist didn't have that, so they're going to do layout. They're going to center punch those, and then they're going to drill and tap these holes over on the drill press. Or they might have used their lathe for this, depending on what machinery they would have had. Float lock vise is an enormous help here because it allows me to clamp the work once and then reposition it as needed. So I'm using the pointer on the other end of my edge finder to get the punch mark centered on the spindle, and then I can lock down the float lock vise in this position, and we're ready to start drilling. One of the things that's getting lost as home hobbyists now all have milling machines is accurate drill press work. Drill presses can be very, very accurate. They just require different ways of thinking and different workflows than a milling machine does because they are a round column machine. So for example, you'll see me doing all of the features for a single hole, changing tools on a single hole before moving on to the next hole. And that maintains my accuracy on this feature. Unlike on a milling machine with a DRO where you can very easily move back and forth between holes, so you can do all your center drills and then all your drills and all your taps. On a drill press, you can't do that. As soon as you move anything, you lose all your accuracy. So even though it's more time consuming to do all this tool changing, it's necessary to maintain accuracy. You'll also see me tapping with the drill chuck, which regular viewers know is not something I love to do. However, it's important for accuracy on the drill press, because normally I would use a spring-loaded tap follower, but that requires a lot more Z height, which means moving the table. And this is a round column machine, which means you cannot move your Z position without losing your X and Y position. So a different technique is required to maintain accuracy. Now I still don't love power tapping with drill chucks, so I use a Tommy bar and tap by hand, but you can power tap if you want. I'm not going to judge you for it. Another example, you may have noticed that I used a stubby drill, or what used to be called screw machine length drills. What that means is I can get the drill in there in the same setup that the tap and the center drill are using, don't have to lower the table. Again, not losing my X and Y position because I had to change my Z position partway through the operation. I'm just scratching the surface here on the different techniques that are used for accurate drill press work. If you're interested in this, for example, if you want to be better with your drill press, or if you have a round column milling machine, which some of the older hobby ones are, then those techniques apply here as well. I recommend checking out some of the older machining books that I've talked about, for example, in my Absolute Beginners playlist. Those old books have the techniques for these machines, where the new ones don't because people don't need to do this stuff anymore, really. This wider shot really shows off the superpower of the float lock vise. The ability to clamp and move the work independently is so nice. This vise is really, really great for accurate drill press work. I do have a playlist on making this vise if you'd like. The design is not mine, but it is freely available. It's linked in that video series. Next is over to the bandsaw to cut these guys apart. One caveat with this method of drilling the holes first and then cutting the edges last is that, of course, your holes are not going to be perfectly centered on each T-nut. I mean, they're going to be close enough. These are T-nuts, they're not fine furniture, but technically, the more accurate way to do this is to finish all the sides of the T-nuts first and then center the holes on them. Just something to be aware of. You could stop here now, perfectly acceptable. Rough edges are fine on T-nuts, but I am going to finish them just for fun. And in fact, I'm going to do something that is normally quite ill-advised. I'm going to set up all 4 pieces at once in the vise in a single setup. You almost never want to do this, and that's because no matter how accurately made you think a set of parts are, one of those parts is always a little bit thicker. That's just physics. And whichever one of those pieces is the thickest will get clamped, and the other 3 are going to be loose, or at least looser. But in rare cases like this one, we can get away with it because I know those pieces are literally within 1,000th of each other. They were all machined from the same block, and I can put a piece of paper in here that is going to be thicker than the variation in the parts. So when I clamp this down, the paper is going to take up the differences, and it's going to ensure that each of the 4 pieces is getting a reasonable amount of clamping. That combined with very light cuts, and we'll get away with it. I would definitely not trust a setup like this for any kind of heavy cut, but it is going to save us a lot of time in this case, so it's worth trying. You can really hear the clapper box doing its work in this setup. It's kind of neat. The clockwork mechanism of this machine never gets old for me. I think it's really cool. The final step for any T-nut is to stake the thread at the bottom. This ensures that bolts that you thread into it can't pass all the way through. That's important because if they can, then they'll bottom out in the bottom of the T-slot, and then they become a screw jack that is now lifting up on the T-nut and pushing up on the tops of your T-slots, which can in fact break them. There are other ways to do this. Some people prefer to simply not tap all the way through. I like this method because it ensures I get the most possible full threads in the T-nut for maximum clamping strength. As you can see now, the punch marks have distorted that bottom thread, so a bolt cannot make it all the way through. It gets stuck, and that's what you want. These are now officially T-nuts. Making these was a really great way to get some seat time on this machine, get comfortable with some new types of setups, and I'm really quite pleased with how these turned out. Now, those shoulders are not going to win any squareness awards, not going to lie. But I got some practice at least at cutting that kind of feature, and I've learned a lot for next time. Most importantly, now I can get my T-nuts back for my small rotary table. It probably would have been a little faster to make these on the milling machine, of course, not going to lie about that, but it was really fun to do it on the shaper, and it's always fun to have machine tools make their own parts. Kind of like a 3D printer, the first thing you do with it is make a bunch of parts for your 3D printer. Machine tools are similar. Well, there you go. There's a very nice set of T-nuts, best viewed from 50 yards away, and don't put any kind of square up to them, but they function as T-nuts, and that's the main thing. Thank you very much for watching. I hope you enjoyed this little tour of the Shaper. They're really neat old machines, a lot of personality. There's nothing quite like them nowadays. I really love it. Thanks to my patrons for making all this happen, and I'll see you next time.